Now you consider the table, this LHS side, roots of the auxiliary equation, this side complementary function yc. Roots of the auxiliary equation real and distinct, that is m equal to, my roots are m1, m2, m3, these three roots are different. Then complementary function yc equal to formula c1 e power m1x plus c2 e power m2x plus c3 e power m3x. This is the formula. For example, roots of the auxiliary equation I got like this: m equal to 1, 2, 3. Then complementary function yc equals to c1 e power x plus c2 e power 2x plus c3 e power 3x. This is nothing but complementary function, first complementary function. If the roots are like this, we will calculate like, we will construct complementary function like this. The second one, suppose roots of the auxiliary equation real equal, real roots, real numbers equal roots, and some roots are different. Some roots are different. For example, means that is m equal to m1, m2, m3. These three roots are equal roots, and m4, m5 are different roots. Then complementary function yc equals to c1 plus c2x plus c3x square. Observe this one, these three roots are equal roots, that's why I am writing like this. This is the formula, standard formula. c1 plus c2x plus c3x square into e power mx. Means first three roots are m1, m2, m3 are equal to m. Already I told you these three roots are equal, and that is equal to m. That's why I am writing here e power mx plus m4, m5 are different. That's why c4 e power m4x plus c5 e power m5x. One thing you have to remember here: 3 roots, 3 constant, 5 roots, 5 constants. First 3 equal roots, for those 3 roots we are getting 3 constants, c1 plus c2x plus c3x square. The next 2 roots are different, c4 and c5. Now this is the second complementary function. First one is all roots are different and real numbers. Second construction of complementary function, some roots are real equal roots and some roots are different. This is the formula. Now third one, I have not taken example here. Suppose m equal to, for the second complementary function, this is the example, m equal to 2, 2, 2. First root is also 2, second root is also 2, third root is also 2. These three are equal roots. The next one, 3 and 4. These two are different. Then the formula is y equals to c1 plus c2x plus c3x square e power 2x, because 3 roots are equal, into e power 2x plus c4 e power 3x plus c5 e power 4x. This is the general example, best example for the second complementary function. Third complementary function, the formula, suppose m equal to, m means roots of the auxiliary equation, f of, already I have taken f of m equal to 0 is the auxiliary equation. M equals to a plus or minus ib, roots are complex numbers. Then the formula is yc equals to e power ax into c1 cos bx plus c2 sin bx. Formula once again, e power ax into c1 cos bx plus c2 sin bx. This is the formula when the roots are complex numbers. For example, m equal to 2 plus or minus 3i, means one root is 2 plus 3i, other root is 2 minus 3i. I am writing combinedly. Here For this example, answer is yc equal to e power 2x, which is real part. That's why I am writing e power 2x into c1 cos 3x plus c2 sin 3x. This is the formula for this problem. Now fourth one, sometimes we will get the complex roots but many times repeating. Suppose if it is repeating twice, means m equal to a plus or minus ib, once again also a plus or minus ib. Two times we are getting the same roots, means for that purpose complex roots but repeated. Formula is yc equal to e power ax bracket flower bracket c1 plus c2x into cos bx plus c3 plus c4x into sin bx. This is the formula. Suppose if it is repeating 3 times, means c1 plus c2x plus c3x square, like that you write it. Now this is the formula. Once again, m equal to a plus or minus ib, and again repeating m equal to a plus or minus ib. The formula is yc equals to e power ax into c1 plus c2x into cos bx plus c3 plus c4x into sin bx. The formula once again repeating here, c1 plus c2x cos bx plus c3 plus c4x sin bx. This is the formula. For example, m equal to 2 plus or minus 3i, 2 plus or minus 3a. Same time it is repeating 2 times. The answer is yc equals to e power 2x into, open the flower bracket, c1 plus c2x into cos 3x plus c3 plus c4x into sin 3x. This is the fourth complementary function. The last, fifth one, complementary function. If m equal to alpha plus or minus root beta. Now here I is missing. This is only different type of roots, alpha plus or minus beta. This is not complex roots. Then the formula is yc equals to e power alpha x into c1 cos h root beta x plus c2 sin h root beta into x. This is the formula. Now suppose 2 plus or minus root 3 is there, then the answer is yc equals to e power 2x into c1 cos h root 2x plus c2 sin h root 2x. This is the hyperbolic function. Now these are the 5 complementary functions. By using these formulas, we will solve the half problem of the given differential equation. Means calculate the complementary functions. This is very important. Now